Hello everyone, welcome to the Stats Corner. The question says that if xy follows bivariate normal distribution with parameter 0, 0, 1, 1 and rho, then what is the moment generating function of x square plus y square minus 2 rho xy? We know that if xy follow bivariate normal distribution, if x y follow bivariate normal distribution with parameters mu x, mu y, sigma x, sigma y, comma rho, then the PDF of bivariate normal distribution is given by 1 upon 2 pi sigma x, sigma y square root of 1 minus rho square into e to the power minus 1 upon 2 1 minus rho square and x minus mu 1 upon sigma x square plus y minus mu y upon sigma y square minus 2 rho x minus mu y divided by mu x divided by sigma x into y minus mu y divided by sigma y. If we put mu x 0, mu y 0, sigma x 1 equals sigma x equals to 1, sigma y equals to 1, then we say that x, y follow bivariate normal distribution with parameter 0, 0, 1, 1, rho. So on the place of mu, we put 0. On the place of sigma x, we put 1. Here 0, here 1. 0, 1, 0, 1. So what will be the PDF? The PDF will be 1 upon 2 pi under root 1 minus rho square e to the power minus 1 upon 2 1 minus rho square. Then this will be x square. Then this will be y square and this will be minus 2 rho xy. Now, if you focus on this exponent here, this quantity and this quantity are same. Okay. So we need to find the moment generating function of this exponent. So whenever we study bivariate normal distribution, we know that this quadratic form x square plus y square minus 2 rho xy follows chi-square distribution with 2 degrees of freedom multiplied by 1 minus rho square. Or we can say that suppose this is denoted by q, quadratic form. So q follows 1 minus rho square into z, where z is chi-square with 2 degrees of freedom. Where z is a variable follows chi-square with 2 degrees of freedom. Okay, so this quantity is nothing but chi-square distribution with 2 degrees of freedom multiplied by 1 minus rho square. Okay, so to find the moment generating function of this quadratic form q, that is x square plus y square minus rho 2 rho xy, which is equals to q, we need to find the moment generating function of z. So if z follows chi-square distribution with n degrees of freedom then moment generating function of z is nothing but 1 minus 2 to the power minus n by 2. So if n equals to 2, then moment generating function of z is 1 minus 2 to the power minus 2 by 2, which is equals to 1 minus 2t minus 1. Now we need to find the moment generating function of q, which is nothing but 1 minus rho square into z. So using the property of moment generating function, we know that if a in we need to find the moment generating function of az, then this is equivalent to at. That is, whatever is in the multiplication of z, just multiply it with t. So on the place of a, we have 1 minus rho square. So we are saying that what will be the moment generating function of 1 minus rho square into z. So this can be written as mz into 1 minus rho square t. Okay, so here is the moment generating function of z. So on the place of t, we have to multiply this t by 1 minus rho square. 1 minus 2, then on the place of t, we have to write 1 minus rho square into t. And this minus power will remain same here. We can write it as 1 minus 2t plus 2t rho square to the power minus 1. So option C will be correct. 1 minus 2t.